confused t something like a time. That's why I took theta. Okay, let me define this unit vector. Let me define this unit vector. Let me define this unit vector. So what is the magnitude of E theta cap and En cap? The magnitude is 1. That this everyone must remember this, because in numericals this data is very important. So let me define first the En cap. So En cap, you are going to write En cos theta I cap plus En sin theta j cap. So there's a coordinate axis. Later on I'll avoid this. You can see that later on I'm going to avoid that I cap j cap terms. Because what is our main goal? We have to eliminate that I cap and j cap. This is the x-axis. And the unit vector directed here will be I cap, and this will be j cap. Okay, fine. So let's write the equation. So En, so this should be equal to how much here? So finally, En should be equal to 1 magnitude. So this En cap equal to cos theta I cap plus sin theta j cap. I'll differentiate this. Let me differentiate here. Den cap by dt. So definition of cos theta minus sin theta d theta I cap plus cos theta d theta by dt j cap. So if d theta by dt, I'll take outside. So this will be minus sin theta I cap plus cos theta j cap d theta by dt. So what is this minus sin theta I cap plus cos theta j cap? I'll define one more quantity. Here ER bar will define it. E theta cap, let me define. So what is E theta cap from the diagram? Minus of E theta sin theta I cap plus E theta cos theta j cap. The magnitude is 1. So sin theta I cap cos theta j cap. So minus sin theta I cap plus cos theta j cap. What I can write as? So den cap dt. So like this, you retain this symbol, no problem. So this bracket term, shall I write E theta cap? D theta by dt. Go back, rate of change of angular displacement. So what you can call this as omega. So therefore, omega E theta. Very important, very good numericals are there based on this. I don't know books why they are not showing this method.
Sir, once you scroll up.
I'll scroll up something. It is yeah, okay, fine. Okay, look at this. So this is the value. So similarly, let me differentiate the like a E theta cap. Then we'll see what will end up here. So I'll differentiate here. I'll do that everything in red color, so that will be easy for you. Let me differentiate here. D E theta cap by dt. This should be equal to minus cos theta d theta by d I cap minus sin theta d theta by dt j cap. So this will become equal to d theta I'll take outside, so minus of d theta by dt I'll take outside, so this will be cos theta I cap plus sin theta. What is cos theta I cap plus sin theta j cap? Should be equal to En cap. So therefore dE theta by dt equal to minus of, this will be omega, no? This is a very basic equations which we need at any cost when we are discussing any numerically. Got this? So these are the things I'll round it off. Okay, let's proceed here now. Now similarly, as the particle moves in circular path, so it will have tangential velocity. Let the speed of that particle vary. So the tangential velocity is directed along this. I can call that as v theta. I'll take help of one more. So the velocity which will be directed in this direction we'll call v theta. Now, but tangential velocity only, since directed along the tangential direction, we'll call v theta. Let this be r. And what about omega here? Omega will be like this. Okay, got this? Now, what is v theta? V theta, can I write r omega? There are two velocities are there. Even r can also be variable. If r is variable, then what when the particle will also have a radial velocity. If r is variable, then the particle is said to also have the radial velocity, dr by dt. So one more, this is I'll do one thing. I'll give some. If you're finding difficult, just think like this. Yeah, this will be r1. Look at this. I'm instead of circular motion, I'm describing curvilinear motion. Then we'll make special cases. It'll be easier. Look at this. It's not a circle, no. Here the particle will have velocity v1. This will be r1. Look at the here the particle is having velocity v2. This is r2. Look at r1, r2 also. They are also varying, no. It can happen. Curvilinear motion it is. Not circular motion. Some random path. So even during a motion, even r can also be variable. A special case of curvilinear motion, circular motion, where r will be constant. So therefore, we define now the quantities like the velocity, this one. So this will be the tangential velocity. So what you can call tangential velocity, and this will be tangential direction. This will be radial direction. Again, we go back to the same way of defining the parameters. So what will be this? This will be tangential, and what about this? This will be radial, no? Unit vector tangential direction and radial direction. So velocity directed along tangential direction, I'll call v theta. And velocity directed along radial direction is called VR. Look at the R. R is also varying here. So two quantities are defined. Now tangential velocity. So what is V theta? V theta is called as tangential velocity. What about VR? VR is called as radial velocity. Of course, we don't discuss any numericals, but let me introduce that also, because last in the end on Saturday I'll discuss some numericals where the radius vector also will be varying. So there, this is going to help us a lot. So dr by dt. So how you define v theta? V theta is given by r omega. What about VR? VR is given by dr by dt. Radial velocity, tangential velocity. And how radial velocity will be acted along the radius vector. And how tangential velocity will be along the tangent to the path. So what about radius? So you draw a normal. That will be the radial direction at that particular point. If you draw a normal at this particular point, there will be in that direction the radial velocity will be acted. What about tangential velocity? In that direction, you draw a tangent. Along the tangent, the tangential velocity will be directed. So we got here r omega dr by dt. Okay, got this. So, and similarly, what is alpha? Already we defined. So here alpha. Alpha, what you can write it as d omega by dt. And the tangential acceleration, already we defined it, a theta. So this should be alpha, no, which is equal to r alpha. This is a tangential acceleration. And an acceleration directed along the radial direction, we'll call that as normal. Radial or normal, any of the things what you can take help of it. Okay, clear this one. So these are some quantities I'm introducing you now. So this is the tangential acceleration. This is the angular acceleration. Okay, let's go for what was our main purpose? A general plane motion. A general plane motion has to be determined. That was our particular goal, no? So I just set up the initial background. So let me go for general plane motion. Let me describe the general plane motion. Okay, this is a circle. The same thing from where I started. I'll continue from there. So this will be R. So this will be En cap, E theta cap. Let this be theta and let it have here velocity. This one. So this is the linear velocity. So like it's having total velocity vector, that is V. Total velocity. Later on I'll write it. So this will be V theta. This will be VR. So what is V bar? In general we write it. Or say I'll start with R bar. I'll start with R bar. So what is R bar vector? According to this, R cos theta. So let me write here. What is the topic? General planar motion. What is R bar? You write R cos theta, I cap, R sin theta, J cap. Let me differentiate this, or in the vector form, how you write it? R into cos theta, I cap, sin theta, J cap. What is cos theta, I cap plus sin theta, J cap? That should be equal to En cap. Already we defined the unit vectors, no? This will be the En cap. No, let me differentiate this. V bar equal to dr bar by dt. Both R as well as, let that be variable. So this will be R into den cap by dt, En cap dr by dt. What is dE n cap by dt? I told you, no? So this will be omega E theta cap. Okay, fine. So I'll write down the conclusion part, what we concluded, no? Already we discussed the background. So those things, let me tabulate here. This will be omega E theta cap. This should be minus. Okay, fine. So what all we earlier discussed, no? So those things, let me keep it. So in place of like a En cap, dEn cap by dt. So I'll write it as omega E theta cap plus En. Now what is dr by dt? This will become radial velocity. Or this will become r omega E theta cap plus Vr. It's only a vector, no? This is dr, Vr into En cap. Okay, not it's only r, no? dr bar by not, only dr by dt. So there's the one equation is what? We got V bar. So in this, let's define things clearly. What is R omega? R omega, just now we wrote, no? What is R omega? V theta, tangential velocity. So I'm indicating the diagram. So V theta equal to R omega. So therefore, R omega, I'll write it as V theta E theta cap. Then what is VR? VR is radial velocity. Keep it here. Sir, if radius constant, put VR 0. Are you getting the idea now? I'm just not describing circular motion. It's a generalized thing. If R constant, VR will become 0. That's all here. In the end, we are going to conclude like this. So what is this? This is a tangential velocity once again, and this is a radial velocity. So let's differentiate this equation. A bar equal to. So how much it is? dV bar by dt. So in the end equation, you'll be surprised. You'll be surprised. Oh, when circular motion something, a particle moves in a curved path, so many parameters will come into picture. So let me differentiate all one by one. So this will be, I should differentiate this equation. So first what will happen? We'll go for derivative of V theta, derivative of E theta cap by dt plus E theta cap dV theta, dV theta by dt. This is a one term. Plus this will be again Vr dEn cap by dt. Now again substitute the original formulas. V theta. What is dE theta cap by dt? From this minus omega En cap plus E theta cap. What is tangential velocity V theta? V theta should be called R omega. So write it R omega. VR dEn cap by dt. dEn cap by dt. Look at this from here. Omega omega E theta cap and dVr by dt. So I'll write it as radial acceleration. There's one more new quantity I've encountered. Let me introduce here. AR equal to let me expand further. So this will be minus V theta omega En cap. E theta. This is UV method. Both R and omega are variable. So what shall I do? So this will be R d omega by dt plus omega dr by dt. Oh, we didn't. Yes, this will be derivative of this we have to do. No? dn cap by dt, what we got? Omega e theta cap, no? Yeah, fine. So the bracket as it is, I'll keep it. VR omega e theta cap en cap into er. Okay, let's expand further. Minus v theta. V theta, what you can write it as? R omega en cap. And just check once. En cap. So this d en cap by d theta is what equal to omega e theta cap. Yeah, okay, fine. Now let's see that. This will be r into e theta cap. What is d omega by dt? We'll write that as alpha, no? So this will be one more step. I'll write it. E theta cap r into alpha plus omega into VR how many terms are there? 1, 2, 3, 4, 5. Okay, shall I scroll up? Just use T once, all of you, because I'll scroll down. V theta is substituted R omega. Just symbols may be confusion. Shall I scroll down? No, this part. This is another bracket, no? So this will be minus R omega square En cap R alpha E theta cap. VR what you can write it as? We can write it as radial velocity. No, don't write VR as this one. So V theta is R omega. Keep it as it is. So omega VR E theta cap. So this will be VR omega E theta cap. Plus this will be AR En cap. I'm interested in only few parameters. So many are there. Let me go for this. So there are 3 parameters along tangential, this particular thing. So these things. So let's go for one by one. If radius is constant, tell me what will happen. I think I can simplify further. Omega square R alpha E theta cap plus 2 VR omega E theta cap AR into En cap. Now, if R is constant, if pure circular motion, if R is constant, if R is constant, and I also say that omega constant. If first let me put r constant. If r constant means what is the path? Path will be a circle. Clear this? So if r constant means, then what is Vr? Will be 0. If Vr 0, then alpha will be, so AR will be 0. Then what is the total equation? It will just end up with A bar equal to minus omega square r En cap plus r alpha E theta cap. Only two accelerations are there. One along normal direction, radial direction, other tangential direction. So in this again, means what are these two accelerations? So if I draw a circle, this is what our syllabus. If you see the books now, they have started from here. They are started from here, but you must know all this, what all I discussed till now. So there are two directions are there. You can see this. A particle moves in a circular path. This is r. R is a constant. So then it will have a tangential speed v, and it will have angular velocity. How will it be directed? Out of the plane. Then it will also have alpha, which will be directed out of the plane. So there are two accelerations are there. What is that? Omega square r. This will call it as normal acceleration. This A bar, I'll put it further. This will be centripetal acceleration. In the books open, they called it as, this will be, and this is the tangential acceleration, A theta, E theta cap. So what is this? There'll be one acceleration called as centripetal acceleration. How will it be directed? In this way. And there'll be another tangential acceleration. It will be directed like this. What about total acceleration vector? So the total acceleration vector will be directed somewhere like this. So this AN will give a one specific name. What is the specific name? I can call this as normal radial acceleration. Normal acceleration or centripetal acceleration. What about A theta? A theta is called as tangential acceleration. What is the total magnitude? The magnitude is given by AN square plus A theta square. This is what the mathematics it is brought here. Okay, fine. If R constant and even V also constant. So what is the strict condition? R constant, V varying. We have this one. Let me put another condition. R constant and V also constant. R constant, even V also constant. If R constant, dr by dt will be 0, Vr 0, Er 0. If V constant, dv by dt. V is nothing but tangential velocity. Okay, fine. So this will be V theta. This will be 0. So if V theta is 0, then definitely what will happen? The A theta will be 0. If A theta is 0, alpha will be 0. So from this, what we can conclude here, it's a condition of uniform circular motion. So then how do that motion will occur? That motion will be particle moves with a constant speed at all the points. V theta, it will be V theta. It will be V theta. R is constant, V theta is also constant. You can see from the diagram now. And then what about the accelerations it will have? Let's go back to the basic definition. What is saying? VR will be 0, AR will be 0, alpha will be 0. So what is only left over? it will have only one acceleration. What is that acceleration? Omega square r en cap. So what is en cap? En cap is radially outward. So therefore it will have one acceleration called as tangential centripetal acceleration. So what is an equal to? An equal to omega square r. We know few formulas. V theta equal to r omega. So in place of omega, you can write V theta by, or you can also write it as V theta square by r. These are the various forms. Or omega r. You can also write it as omega r into omega. So what is omega r? Will be V theta. So this is called as centripetal acceleration. I think you are very familiar with this. Rather than radial acceleration, the better call centripetal acceleration. Okay, this is a condition of uniform circular motion. Uniform circular motion. What about the time period? Because it take time period. So what is the time period? We define the time period. We define it as the time period. We define as distance covered by tangential speed. So this should be equal to t is equal to distance covered in one revolution 2 pi r with a tangential speed. So like this, what happened? We can define now the time period here. Then what about angular velocity? It is related to by time period by this particular formula. Because we know how do you brought it? Okay, we'll do one thing. How do I wrote it? We know r by omega, r by v theta. What you can write it as 1 by omega. So how time period and angular velocity are related by this particular formula. So got this about the uniform circular motion. See how I should arrive till here from the basic mathematics from there. This is the general planar motion. So now if you have any radius varying, you need not to get scared. Take help of that particular formula. Okay, you can take help of the basic formula. If radius, I started from here. This is a non-uniform circular motion. This is the example of non-uniform. Our syllabus is maximum non-uniform uniform circular motion. Then some numericals of planar motion will go for it. General formula not needed. Just I brought it because say what all we discussed now, we should come from there. The special cases of the general planar motion is what? Uniform and non-uniform circular motion. Got it, all of you? Now there are two accelerations are there, no? This called like a